All right, I'm live and I'm going to be talking about Onnx. Get into it. So, Onnx, in a nutshell, what's kind of fun about it is that it is this open standard for machine learning interoperability. And what's cool about it is that you can use many different frameworks. So, you can use everything from a Keras, PyTorch, TensorFlow, etc. And then the other one that's kind of interesting is that you can see that you can do inference on those models, basically on these cloud services. And then also you can use accelerators as well, which are also a great way to use Onnx. And so one of the things that's kind of fun about Onnx here, if we take a look at it, is that if we go to Onnx Rust, you can see that there is a crate here that's available. And we can see that this is a safe wrapper around Onnx runtime from its C API and from its GitHub pages. Onnx runtime is a cross-platform high-performance ML inferencing and training accelerator here. And there's a C++ example that was ported. Now, what's also nice is that this has actually been put into the Microsoft runtime right here. And we can see, in fact, that look, run Rust format in continuous integration. It's actually being actively worked on right now, which is pretty cool, actually, if you take a look at this. And so this is really the Onnx in a nutshell here. And if we look at the build status, we can see that we've got Linux support, Mac support, iOS support. So that's the other thing that's kind of nice, is that it has this runtime that is able to work on all these different platforms as well. And so in a nutshell, one of the things that we probably would want to do to play around with this is to just create a project that uses Onnx so we can kick the tires on it. So what I can do here is go over to my MLOps template here, and I can actually just launch it with code spaces. Let's go ahead and do that. And what's fun about this is, again, that it has this portability associated with it. So let's let this thing wake up, and why don't we make a new Onnx project here from scratch. So I'm going to go ahead and say cargo new, and we can say, actually see if there's some examples in this Rust repo right here. We have Rust bindings, and we have a couple examples. So let's see if we can run the official ones from the Microsoft branch here. That was probably a good place to play around with it. So let's see. The high level ones are this one, which would be this repo. An example. Here's a sample right here where we can look at what library do they have running here. Let's see. Oh, SqueezeNet Onnx. Okay, so this would be a good one to play around with a little bit. So let's go ahead and do that. So I'm gonna go over to this repo, and we'll call this new Onnx MS SqueezeNet. Let's have that. Our new Onnx MS SqueezeNet. Okay. And if we go into this repo or directory, you can see the structure. And inside of the structure, we would have to set up the dependencies. So for the dependencies, this will be kind of interesting, is I believe that now that it's been ported, we can do an installation by just following the instructions here. So if we go to this version here, go back to index, and we just go to create Onnx, and we paste this in, use Onnx runtime. Yeah, this is one thing I sometimes I mess up on with the way that Cargo works, is that to get to where they give you the latest, okay, there we go, the latest version, we could click onto the home page. That's one way to do it. Or we could also click, well, we could just copy this version, I guess. Onnx runtime. Let's go ahead and do that. So we'll say Onnx. Actually, let's just take a look at one of my other Onnx examples here. Let's look at this. So that looks like the latest one. Let's just do that. Let's keep it simple. We go here. And to make it kind of simple as well, we'll just start, we'll stay with their example here from the Microsoft repo. So I'm gonna just copy and paste this and just tweak it a little bit. So we'll go here and we'll just stay with the main here and do that. So the other thing that I typically like to do as well is put a makefile inside. Wish I could automate this actually, but basically I'll copy one from above. So I'll say CP Onnx EFS Lambda file here. Okay, let's try that. And if we look at this makefile, we don't need this release and deploy because we're not going to do Lambda, but we do want the rest of this, right? Which is format lint run. Okay, perfect. So let's go ahead and run this. So we'll say make format. Okay, that's good. And we'll say make lint. See if the lint passes. So once this lint passes, then we'll be able to tweak this example here a little bit. And I guess what I could do as well to kind of mix things up today is let's throw our friend ChatGPT in here, and let's see if we can play around with that and get anything good. Okay, so use of undeclared create our module tracing subscriber. So tracing, if I look at this other example here, tracing subscriber, let's throw those in. So it does pay to have a previous example to look at because it can prevent, installation issues. Okay, so no method named with library path. That's interesting. So that error, and we also don't have the SqueezeNet model, which we should probably look at, see what models are available. And we see SqueezeNet 12 here. So let's grab that one. And let's go ahead and say curl -lo. And oops. Let's just change this first part here, which is get this here. And then we can do SqueezeNet via version 12 here. So let's go back. Version 12. There we go. All right, so let's change that as well. to this version. Okay. And then let's double check with that's line 33 with builder. I wonder if, what is that problem with library path? That's strange that that is not popping up here, but no matter with library path found per struct in the current scope. Onnx runtime. I can look at my other example that I had earlier. I guess what I could do is copy an example I know that works. Why don't we do that? So I'm just going to copy my other example that I know works. So I'm going to say here like that. And then if I look at the other example in their main, we can also do, here's the lib, and then the main is here. Run it. That's the main. Let's get this here. So why does that run it? That's weird. I think I might have, I screwed that one up. I screwed up the copy paste here. So this one is closer, and we can say build it. So it returns them. Let's see what happens if I just run this. Say def function main. Oh, I see. So this is still the same. This is still the same model. So I guess that's the real question here: is why am I getting this build not found here? I guess I could try to rebuild it. Yellow path. Let's try that. Builder dot let builder if some builder. Let's go. Let's take a look at the official documentation here. So the previous page that ran this. So we've got this one as the new one, but where's the old version of it? Here we go. Here's this one. Run this, see examples, and there's this example. Okay, yeah, so this is the older example. And let's see here. So this, let's just try this example actually. Let's try this one. So let's throw this in. And that does work. So the example that was in the repo is a little bit wacky. And then we'll change the model to this one. Go run it again. And if we say should just compile it, or cargo run either one, they're both the same length. Then we're going to compile and see what happens. Well, there we go. So we got something working. So the I guess what would be kind of fun is instead of creating a shape here, it would be nice to see basically an example that loads with an image. That might take a little bit more time to do, but I guess in a nutshell, that's a really quick and dirty Onnx example. I went through some difficulties with getting it to build, but let me go ahead and check this in. I'm gonna go ahead and here get add Onnx and see example working build. So yeah, what would be nice is to go beyond just this hello world example and get an actual image loaded and pass it into command line tool. There are some other examples of that. So there was like track Onnx that I've seen. Sonos tracks. What was one that looked pretty interesting that did this, and they have some quick starts here. And so this one can read in Onnx or NNEF, optimize it and run it. So this is another one that's actually pretty interesting because it's a Rust-based project that you can load in these Onnx models. And then there's another one that I just saw as well, which is called I think it's called Rust Code Search GitHub. And I thought that there was another bloop. There you go. Yeah, so I saw this one was kind of interesting. This project also has yet another Onnx runtime wrapper. So this one would be kind of interesting to see if I can play around with this. Let's see if they have any examples. So there's another example for Rust. There's a bunch of cargo features. It works with CUDA. Okay, Linux, Mac. Okay, so do they have examples? They have examples here. So GPT RS. Here's one. So what does this do? So this allows us to use GPT-2, also CUDA if it's available, and you would need to get the vocab.json. So I guess this might be checked into this project. Let's see here. So this is under, if we say from files test, the data, GPT-2. Okay, so merges vocab. Okay, so this might work. So what I could do is just try this project out. Okay, let's try it. I was kind of curious about this project. So let's go here and go to just HTTPS because I'm not going to push back changes. And what I can do is just git clone this. And if I go into this ORT, you can take a look at this. So ORT here, another wrapper, got all this. We want to go to examples here. And I believe, do they have some documentation here for this? Motivation. No, wrong one. That's my stuff. We'll look on this README. ORT. Do they have examples? If I remember correctly, with cargo, you say cargo run. So how to run examples. Cargo, how to run examples. Just to double check. examples. If you do -s example, I think that's how you typically do this. So you say cargo run -s example, and then this one would be GPT. That work? Yes, it does. Okay. And let's try this out. So this example looks a little more realistic actually, because this Onnx binding is actually using GPT-2. There's CUDA hooked in. And what is it going to do here? No. Oh. So it's basically just generating a bunch of test output. So I mean, it looks kind of interesting actually. This is actually promising. So um, I guess maybe as an action item here, this does look very interesting. These Onnx runtime Rust bindings, especially the examples here. So it looks like there might be a more short-term traction with these Onnx bindings, and I guess it's encoding this is the message. And now what is the rest of what it's going to do? It says is known as a core 6. So I guess it's trying to get generation, right? So then it's so probably wouldn't be generated tokens. I see. So so basically it's looping and giving up code completion or text completion here, and then printing them out. So it looks like there's some promise here in terms of playing around with this. I definitely would be curious to play around with this some more. So probably the next time I play around with Onnx, I think I will play around with this particular version. It does look very interesting. So I think I'm gonna call it a day for what I was trying to play around with, which was get a couple different Onnx bindings uh, kicking, and go from there. I guess next time I'll try to build something a little more substantial. But thanks for hanging in there. All right, see you later.